people who like to make the charts. I'm going to be honest with you, it's usually girls because it's nice and organized. It's girls who have very neat bedrooms, type A personalities. They like to do the chart. If you're going to do a chart, make sure you think X's are this way, Y's are this way. We start in the top left corner when you make the chart. That way all your tan lines can go with your chart formation. But this one, watch what happens when you make a chart. The derivative is only dependent on the y value. It says right here, dy dx is just y, right? This is negative 3, 3, negative 2, 3, negative 1, 3. The y's everywhere here are 3. So that whole column is going to be a 3. How about the next column? It's all going to be a 2. And then this is all, so I wouldn't make a chart for this one. Some books teach charts. I only make a chart when it's a derivative that's a pain in the butt. But this one, it's just the y value. But watch what happens, how quickly it graphs itself. So we go to the top left, and everywhere along there, we make a very steep uphill line. 3, 3, 3, 3, 3. And then 2, so a little less steep. 2, 2, 2, and it's just taking time. 1, 1, 1, 1, 1, 1. And then little ones like this, 0, 0, 0, 0, 0, 0, 0. And then likewise, it's going to be the similar down here. So it's going to be negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. You guys can go finish drawing that. When you're done, you've got yourself a slope field. All right, now it says find the solution going through, and my thing's blocking it. What point does this say here? 1, 1. That means you're going to drop your feather right there, and you have to draw that dot. The rest of it, you're just going with the flow. So you're going to send yourself as if the wind is going this way, and it's going to pull it right up like that. You don't have to hit the red lines. You just have to go with the flow. When the feather floats to the left, it goes like this, and will it ever pass here? No, it won't. And that should look really familiar to you. What is that the graph of? It's not a parabola or a line or anything. It's exponential growth is what it looks like. Well, this one actually is solvable with analytical methods. Watch. It was the derivative everywhere is the y value. Let's solve it. Why can't I solve it? I don't need a slope field for this one. It's separable, right? How would I separate this one? Divide by y, and we can do it quickly because you had way harder ones on your homework. So I'm going to do this one analytically, not graphically. I'm going to go actually and crank it out. I don't want a visual. I want to know what it is. Well, then I integrate. What's the antiderivative of 1 over y? ln. Excellent. So you guys are really smart. All right, so we've got ln, absolute value of y, is equal to x plus c. Our goal is to attack y. You guys already said, oh, it's exponential growth. It sure is. And we're going to even get the actual base of it, because when I exponentiate both sides of this, right, what's e to the ln y? Yep, absolute value of y. How did we tell you to tackle that analytically? What is that going to be? E to the x times e to the c. Exactly. Let's go do that. Those of you who did your homework, which is pretty much everybody, what did we call this? Some other constant. So my y is going to be equal to technically plus or minus c, because I didn't write that I'm absorbing the absolute value. So if you want to write it like that, that's fine. Or you could write c equals plus or minus and absorb it that way. But that sure looks like e to the x, doesn't it? And it looks good. Now watch the next one. The next one is going to be a lot... I'm going to go back up here. It's going to be different, but you can kind of, if you really get it, you can anticipate. I'm going to move that down a little bit. First of all, I forgot to write about the symmetry up here. Write this. There's horizontal symmetry. I can barely reach. Horizontal symmetry on this one. Like everywhere, you're seeing sames along the horizontal lines, and that's because there's no x in the derivative. Right here, it's only, go circle that, it's only dependent on y. And so when that happens, it helps with multiple choice. Like when they'll say, which one of these is the graph of? And if you're like, oh, it's only got y in it, you're looking for horizontal symmetry all across the board. Watch this one. Can you anticipate what I'm going to see when I squint and go with the flow? What's the antiderivative of 1 over x? ln x. Do you know what the graph of ln x looks like? That, exactly. When I'm done making my slope field and I go with the flow, I'm gonna see that motion because I already know this one. But let's go do it really quickly. It says to do 1 over the x value. First of all, is there anywhere where my slope's gonna be 0? Yes or no? No. How does that correspond to what we know? The ln function's always increasing, so there's no way I'm gonna get a slope of 0 anyway. Anywhere where the slope is undefined or infinity? Anywhere x is what? 0. So go like this. I look for the zeros and the infinities first. So all the way on down here. What does that mean I'm going to make on my slope field? Little verticals. Okay, so all these, that's your asymptote really analytically. Next, I'm just going to go to the top left corner and start cranking this sucker out. It's, again, these are the x's, these are the y's. The y's have nothing to do with it because they're not in my derivative. So I just do 1 over the x. So 1 over negative 3, 1 over negative 3, 1 over negative 3, etc. What's going to happen in the next column? Negative 1/2, all down. Next column, negative 1, all down. 1 over x is 1, on down, 2, on down. So it doesn't need to be as labor intensive as some of you type A personalities are going to make it. Try not to be type A. If you can't help it, go ahead and fill in every little box. But honestly, most people don't even make a chart once they get pretty good at these. So let's go crank this out. I'm going to make sure my ones and negative ones are pretty set and everything else will be relative to those. So this was a 1, so nice 45s. Your ones, negative ones, zeros, and infinities need to be pretty good. Okay, and so my negative ones are like this. It's looking kind of like a fish spine here, right? And then on the other ones, they just start getting steeper over here. So this is up at, oh, that should be 1/2. Why didn't anybody fix that for me? All right, anyway, a little less gradual. A little more gradual, I mean. 1/2 and then 1/3. So you can kind of see it forming, and then again here, you can finish that off, but let's just do one solution curve through 1, 1. I'm dropping the feather right there, and it's right over this wind current. If it blows this way, it's going to be going like that. If it blows this way, it's going to hit the wall, and it's just going to fall on down there. What does that look like the graph of? Somebody first hour said the square root function. And I had to pause. I pause for a second when I hear stuff like that because that's really good thinking. Can you tell me why that couldn't be? It's a good competitor. Like if you were matching and you're like, ooh, square root's there. Down here, you can't root negatives, right? But if it had just been that, I would be torn. Is this square root or natural log? Well, they both wouldn't be there if you were doing multiple choice. So it was good thinking, but not quite. All right, we are nearly done. So now what I'm going to do here is make one that does not have obvious symmetry and that actually is kind of all murky in here and show you how to tackle that. So this one, will this have any nice horizontal or vertical symmetry? Horizontal or vertical? What's the answer? No, it's dependent upon both x and both y's, which means it's going to be kind of like a very counter. It's kind of like the wind when they're butting up against each other. It's not going to be a nice flow, but we still can go and get a good idea. Could you separate this one? No, I don't even think this one's solvable with higher level. Like, I don't think this is a solvable differential equation even with Calc 4. I just think it's one of the ones that you'll see when I expand it out and you see the whole picture. It's a little funky. All right, so let's go. It's not a circle. No, because this is its derivative. You know what I mean? This is not the function itself. The function itself, I have no clue what it looks like. Let's go just crank it out. Let's go to the top left corner and let's put in a -1 and a 1. What's the slope? 1. Go like that. And anywhere you can take shortcuts, I never say this, with slope fields, if you ever spot a shortcut, take it immediately. So if you go here next, and Haley's like, okay, if I put in a 0 and a 1, I'm going to get 1, or sorry, 0, 1, I'm going to get 0, right? Isn't that true? Okay, How about if I put in a 1 and a 1? 1 squared plus 1 squared minus 1. What's that going to give me? 1. All right, let's see. How about if I put in a 0? Negative 1. Oh man, this is all over the place. How about if I put in a 1? 1. What am I going to get? There, right? Then I'm just plug and chug. That's all I'm doing. Negative 1, 0. What's that going to give me? 0, right? I've got one of them wrong, don't I? This one. Yep. Actually, this one's going to be 0 too. All those are 0 because they all have a 1 and then a 0 in the other one. How about negative 1, negative 1? 1. And how about this one over here? 1. All right. And if you spotted, this did have pattern to it, but it didn't have symmetry. Now watch. I could not have separated that one, but when I blew it up using computer software, we were focusing in here. So it was really hard. If I told you to go with the flow, you would have been like, what? It's all over. But when I kind of step back and I do a whole bunch of them, do you see the currents forming? You know what I mean? It's kind of like if you're standing right where it's windy, it's kind of like, what? But if you're above charting it all, you can kind of see the different wind patterns. This is really weird. I had a bonfire the other day. It just sitting back there with my dog, and I had this little wiener dog on my lap, and the smoke kept coming in his face, and he's like, bah, bah. So I moved my chair, and then the smoke was blowing right in his face, and I moved the chair, smoke blowing. I did 360, and I never got a spot. How is that possible? That the wind was blowing smoke in my face, every place. I have to, and that'll stop the smoke from blowing in your face? I seriously, and I like would pick up the dog, pick up the lawn chair, then I had a book, and I'd move over a foot, and I'd sit down and be and then it'd all come in my face. So I'd pick what? Oh, yes. Sorry. Yes, I did forget. All right, so we're on our last one because we did this one already. We did the x plus y on a previous one. Watch what happens over here. And again, I'm a little off center. If you're watching the notes, there are a zillion people gone. Oh, there we go. Watch what happens, and let's take some shortcuts. If I'm going to make the chart, here's where I look first. Where are the slopes 0? Because those are my best favorite to draw. Anywhere, what happens? X is 0. So anywhere X is 0, I'm going to go 0, 0, 0, 0, 0, 0. Where's it going to be infinity? Anywhere what? Y equals 0. Why am I leaving the center one undone? That's 0 over 0, and I cannot make a tick mark there. Okay, you're going to see why when you see the solution curves. Now, what else would be helpful? Let's just start and see if we can see some patterns. The opposite of x over y right here would be a negative, negative 3 over 3, it's 1. Where else would I get a 1? Can you see it? Because if it's shortcuts. What'd you say, Cam? Yeah, well, sure. Over here I'll have a 1. Anywhere else? There it is. Minute you see that, bam, 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 bam. You just got 6 things. Where's another good spot to go fill them in? The other corners. What's this? There. See what I mean? I said anytime you can find shortcuts, take them. And then I'd stop because those are our 4 besties. And let's go put them in the grid, and maybe you'll see something forming, and you can avoid the rest of it. The first year I taught this, we made the whole chart. And we plotted them all. And I was like, why are we doing that? It was so overkill. It wasn't necessary. You just need to get the general flow. So anywhere x is 0, you're going to go like this, but not at the center. There is no tick there. Anywhere y is 0, you're going to do your verticals. Along the diagonal right here, you're going to do positive 1s, right? So you're going to go like this. Along the other diagonal, you're going to do negative 1s, and maybe if we squint, we might see something forming, or maybe we can still do some more circles, and it will be. Like if you were to go over here, right, suppose we went to negative 3, 2, right here, it would be 3 halves. It'd be a little bit more steep, but then this would go gradual. This would be even steeper, but it's going to start to, if you go start making them, you're going to see a circular slope field appear. You can go fill them in then. You do not need to do the whole chart. You can just go, okay, I see that we're going to be following. You can just kind of manually. College Board only looks for your zeros, your infinities, and everything else relative to the ones. So you don't need to be spot on. If you're type A and you want to go plot them, I'll go ahead. All right, now it says the solution curve. So I'm going to drop the feather at 1, 1. Where's the current going to take me? Well, when I go to the left, it's going to come around like this. It's going to go like that. See what I mean? It's easy. However, and I'm not going to do the other one because you guys totally get this. It says which two of those up above is separable? The one on the left or the one on the right? Now watch me do it just so you can see it. It was negative x over y, and I'm going to go really fast with the analytics or the algebra of this, but watch what forms. When I separate y dy, see if you can keep up with me, negative x dx, right? Integrate. Y squared over 2, negative x squared over 2 plus, watch what Carl ends up being in this particular differential equation. Double everything. Make even a bigger Carl. Now, if I solved for y, that'd be fine, but I'm going to write it like this so that you can actually see it. What is that? That's the general formula for a circle centered at the origin. What is C in this scenario? It's affecting the radius. Yeah, it's the radius that's changing. It's not like a shift up and down the screen. So for your homework, I'm going to pause. Actually, I'll keep this going. What I want you to work on today, and watch how quickly this is going to go. Take your work packet out. First of all, you're going to make 6 slope fields, but they should go very quickly. By the way, keep in mind you're given the derivatives, so you kind of know on some of them what they're going to look like. Watch. Let's go do number 1 together. Are you ready? Number 1, where would the derivative be 0? Because that's always where we start. Everywhere what? X equals negative 1. So what you're going to do immediately is go like this. At x equals negative 1, on those tick marks, go like that. That's it, okay? Then, once you start making your slope field, everywhere x is 0, what's it going to do? 1, you're going to go like that. That also happens at negative 1. And you squint, and you start to see something forming. Go ahead, you can make them really fast. Go make the one for number 1, and squint. That's perfect. At 1, it's going to be even steeper. It's going to go like this. You're just doing the x value plus 1. If you were to go with the flow, what are you looking at? That shouldn't shock you because the derivative was a line or was linear of first degree. So what should the original have been? Second degree. See what I mean? Now flip the page, and when you're playing matching game, watch how easy this is. It looks like a big, huge page of work, but this is about a 1-minute problem here on the next page. Because all you need to do is go squint and go with the flow. And you can match graph with equation or equation with graph. I'm going to just kind of squint and go with the flow. I see with my little eye, with letter C, parabolas. Don't you? If you go with the flow, which one down there is a parabolic equation? 9. Yep. So that would be 9. So just kind of squint and go with the flow. Oh, let's find another really easy one. I spy with my little eye. Yeah, hello. D is which one? What equation is that one? Y equals 1. Yeah, the slope would be 0 everywhere. So that one would be, yep, that's not this one. You're looking at the original equation. Anyway, last up, before I leave you, I would like you to get through page 8, but go to page 8 and let's do 15, 16, 17. It's matching game. We're going to crank it out. Now you're matching the derivative with the graph. So you're not squinting and going with the flow. You're thinking of tangent lines. So let's look at that. Are you ready? Which one has horizontal symmetry? A, B, C, or D? I'm just hopping in here. Which one has oops. D does. So who does D have to go with? 17. Which one has vertical symmetry? B. Who does that have to go with? 15. Another way of thinking about, there's lots of ways to think about it. Another way is if the derivative is linear on number 15, the original was quadratic. So I should be looking at parabolas. All right. How about which one? We already did the circle. Which one did that go with? That went with 18. And I want, even though 16 is by default, take a look at 16. Where would the derivative equal 0? Everywhere that y equals x, correct? So along the line y equals x for that one, you'd be seeing these little marks. So you take as many shortcuts, which I never say, as you want to on these. It's all just about getting it matched with the correct graph. All right, so if you could get through page 8, it'd take you about 10 minutes. So not a whole lot of homework, but juniors, you guys have an ACT test coming up, and some of my seniors in my first hour we're trying to improve their score on the last one in December, and they did just this geometry packet that I made, and one went up 5 points just by doing that, because you guys will have forgotten your geometry. Everything else will be fine, but there's a ton of geometry on the ACT. So juniors, if you would like to grab one of these, you can. Do the seniors